Hello, I'm the Blue Car in Wings, and today we're going to be updating this Busby automatic Tommy 20 to work with modern darts. Admittedly, as you can see, I've actually already started doing some with this. I did start this about 2 years ago for my child, but in a rush to get it done, some things were not quite right, so I basically got to redo the entire thing. So the first step is I'm just going to take it apart and talk you through what I did do and then what I'm gonna do to basically actually make it work this time. So originally this was just 3 actually double A's, which would have made 4.5 volts. I'm going to run this, was going to run this on 2S, which is, I've forgotten, 7.2. So just about double, so we'll double the rate of fire, but at the time I was just like, get this done. This was actually a similar time that I did the Fearless Fire. So I've got 2 different types of just bought off eBay MOSFET boards, because a bit nervous discussing MOSFET boards, so I thought I'll just buy some random Chinese ones and see what they look like. So I've got one, I think this one, in the Fearless Fire. You can check out that video, and I only had 2 of them. So the one's here and the other one is here. Some of them have got solder connections, but they've also got screw posts, which kind of makes it a little bit easier in some respects. Like I just put them in and screw them, but I just wanted to see whether it worked. Being a 2S build, I decided to use a Dean's here. Now, oops. So those were the 2 bits that went in there, and that would have doubled the rate of fire really, if, you know, from 4.5 to 7.2. So what went wrong? Well, first on the list is this flywheel cage. It's the one that's off the Thingiverse. At the time, I didn't actually have a 3D printer, so I got my mate who did have one to do it. He didn't fancy doing a print with lots of supports on, so he split it across the middle. And when I glued it together, I didn't quite get it fully together, so it's offset. AAA battery connector in there just to wedge it in place, so I was never really happy with this. But because in a rush, I thought I'd just get it done. But now I'm opening it again, I might as well do it properly. And actually, this is how long it was ago it was. I didn't actually have a 3D printer still when I got Ratman to reprint me this, and he just printed it solid. Flywheel's off, motor's out, shove it into here, then back on, and hopefully that is done. But marginally shorter, and the darts would catch on here. I mean, only like a mil or 2. So what I was originally hoping to do was, could I just adjust this basically? But I think after taking it out and looking at it, it's like, well, no, I can't actually just push this a bit more there because of the spacing. Then I wanted to see whether I could sink this a bit further, so I kind of took this off, and I came to the decision I came to that no, I couldn't actually take this bit off and just, you know, shave a bit off there and push the entire drum back a bit. Unfortunately, when I put it back on, I didn't put this bit on quite right, because like any foam dart revolver you're familiar with, it's got these little ramps on here, and they're just offset from each other, so as you go forwards and backwards it moves it around. But because I put it on wrong, it ended up being ever so slightly out of sync. But because it was a worm gear, it just kept driving the gears. But because also it wasn't tied down at the end, rather than stalling, the shaft would flex right over the gears and then snap back down. So it's not as bad as I remember, but I do remember it a flat spot on the gears somewhere. Ah, yeah, there they are. Now, Suez, this is back in Foam Fest 2019, 2 years ago now. He luckily had a spare Busby Auto 20 gearbox just lying around. See, I'm only going to swap the gear that wore out. What else I'm also going to do is, because this will be running quite a bit faster, and maybe that's part of the problem, Boff of Boff-Tac designed some little circuit boards, and one of them was a voltage regulator board. Now that voltage regulator board, I think he designed it to take in whatever and just output 5 volts. It uses, so it looks like a MOSFET, it's like another 3-pin package. However, you can set the output voltage based on resistors. So if you put fixed resistors, you get a fixed voltage out. What I'm going to do is put in a variable resistor, which means I can alter the output voltage from it, and I'm going to use it to drive this motor. I'm going to put in that voltage regulator board, which gives the option to run it, I think, a little bit slower than stock to, I don't know, off the top of my head, about twice as fast or something, which would be nice because that'll give us a rate of fire control. And to let us know what that's doing, I'm going to try and put in a little voltage meter as well. But that'll be a bunch of soldering and messing around, and you're not going to be interested in that. So hopefully when you see me again in the next 2 seconds, it'll all be done. These are the various components I'm going to use to make the pusher motor variable. Let's just see if I can zoom in a bit. What have I got here and what is the plan? This is a variable voltage circuit board thing designed by Boff of BoffTac. I will link the original forum thread for you. He also kindly supplied me with whatever this thing is that does the actual voltage regulation. LM338T written on it. Looks like, but it's not actually a MOSFET. But this goes into the board. Now, it's designed to turn a whatever into 5 volts. And my plan is to use it with a 7.2 2S LiPo, so I can output a variable voltage to enable me the Autotomy 20 push box to either be, I think, half the speed or double the speed compared to standard. And it works by using this. And this gets its various cues from a voltage across one resistor, which will go into slot 1, compared against the voltage across a second resistor. Now if you use a fixed resistor, you get a fixed voltage out of it. My plan is to use a variable resistor. That resistor goes across resistor 2. Here and here you've got some little smoothing capacitors. It's not labelled, but I have checked with Boff. This is capacitor 1, that needs a 0.1 capacitor, and this is a 1 capacitor. Oh, I'm using a 400 ohms resistor there, and like I said, this should be 0 to 1000. Your input voltage will come here from the battery, and this will be the feed to the motor. Also, you may have noticed this. That's sold by UK Nerfwall, but it's one of those small generic kind of little voltmeters, and I want to have this in line, in parallel with the output. It will report what the voltage is, which will give you some idea what speed you've got the motor set to, or at least the ranges. And I've got a little 3D printed shroud. Because these are basically quite common components, I had a look around on Thingiverse till I found something that matched. But I need to figure out where I'm going to fit all of that to set blaster. So my plan is to have the variable resistor here, because it's still quite close to play with, and there should be just enough space behind to clear the trigger, and to have a little voltage report here, because it should be close enough to where the circuit's going to be. But you've got to think about what's inside as well. Because even though it overlaps the sticker, the switches behind this are actually using 2 very exposed switches, and the first one is for the motor and the next one is for the pusher. But yeah, so that'll sit back there and this will sit here. Apart from it can't sit all the way forwards because there's a post here, so there'll be some fiddling as I figure out where exactly that goes. Okay, I've just done the majority of the soldering on here. We've got the voltage regulator on, the 2 capacitors, which I think probably do some smoothing, resistor 1, which I was going to use a 400 ohm resistor for. I think it's a 390 because that's what I've got in my gear, but it works enough. These 2 blue leads go across resistor 2, and as this sits on one side of the battery box, these will go under the battery box to the other side to the variable resistor that I'm going to go through the shell. So this means I can just have the resistor remote to this. We've got the leads from the battery, which in this instance will actually be the MOSFET that is being driven by the switch, which would, yeah, eventually drive the pusher. And the pusher itself will be driven from here. I will also be attaching in the voltage meter to there, but I'll probably do that at the same time I actually put this in the shell. Okay, we've done a bunch of wiring. Let me explain what's going on here. First, we've got this 2S LiPo. I actually bought this from my work at Hurricane, and now it just powers everything. This is the stock battery box, which it goes through. It's all in the back there. On the back, that screw's just escaped. Can you even see that? So I've kind of got live wires everywhere. I suppose this is not a good idea. Well, you'll just have to kind of believe me. I don't want to destroy the soldering. But on the back here, we've got 2 little reed switches, and there's this trigger goes backwards, it sets off these two little switches. It's two-stage trigger. Your first set here hits the first switch, which is your flywheels, and the second one is the pusher motor, which I'll come to in a minute. But see, the battery goes through here and it goes to this little MOSFET board here. These two little switches, two little wires go to the switch. There's a red one here, and yes, it's red from both, but this goes to a black one to the ground. And the other side of this little MOSFET board powers the flywheel motors. It also takes a feed, this wire that goes to this second MOSFET board. This MOSFET board is driven by the second little switch, which then goes to the voltage regulator board and goes to the motor. Here there's a little battery display, little voltmeter, and here is the potentiometer used to control the speed. Now the mistake I've made here is that the MOSFET, which is a switch, controls the voltage regulator board, which has the voltmeter on it. Which means this is only ever you're never going to see this when the pusher motor is activated. If I had some brains, I would have done it the other way around, had it so that it's applied this board, so you could always see the voltmeter, and then supply the MOSFET switch, and then to the pusher motor. So this kind of means you won't know what your voltage is, but chances are you just be doing it more by feel anyway. So we'll just turn on the pusher motor, and the voltage is too low to show this. Here's the potentiometer. Getting faster. Oh. It turns on at 2.3 volts. 2.3 volts to turn on. So 2.3 volts turn on, 4.58 volts off. Which, interestingly enough, 4.5 volts is what we started with originally. I get a feeling I thought this would be 3 to 7 volts. So maybe in future I would, you know, put a different resistor on there. I suppose I could put a second potentiometer to get even more fine control over it. But yes, I'm going to say that actually works. Of course, now I need to put all this back together. So here we go. Here. Oh. Darts are a little bit loose in the drum.
Yeah.
And they go forwards a bit and get caught. Yes, they're fine.
I'm okay.
Good job, I can edit some of this out. Right, so make sure it's a little bit pointed up a bit. So there we go, there was some firing footage. Now, the dart tips still do catch a little bit on the, in focus here, we go. So the dart tips still do catch a bit on the front of the faceplate there. It's good enough. I mean, I could maybe with the next version trim down the face a bit, and also darts themselves are a little bit loose in the drum, so you've got to make sure you have it angled up so they don't fall out as opposed to down and falling out, which you may have noticed on some of the footage back there when my daughter was holding it. But there you go. It's taken 2 years or so, but finally it's finished. Okay, great. Thanks for watching and catch you later. Bye.